Hey everybody, this is a tutorial on how to complete a Punnett square for a trait that has multiple alleles. Now remember, alleles are different versions of a trait, and so far we have talked about complete dominance and incomplete dominance. And in those two cases, there were always just two versions of an allele. But there are actually several situations where there could be multiple, more than two different versions of an allele. One example is in peppers. The color of the pepper is determined by several different alleles. So you could have lots of different combinations, which gives you lots of different color peppers. We also have probably our most common example that we use is blood type for multiple alleles. Your blood type, you could have type A blood, B blood, or O blood. Your blood type is determined by three different possible alleles, and there's lots of combinations of those three alleles. So there's an A allele, there's a B allele, and there's an O allele. A and B, type A, B, and B blood, you can get A blood if you are homozygous for A, which means you have two A alleles, or you could be heterozygous for A, which means you have A and O. That tells you something. That tells you that that O allele is actually recessive. A is dominant. Now, B blood, you could have type BB, that would be homozygous for B. You could also have type BO, that would be your genotype, that would give you type B blood. There again, B is dominant to O. So what happens if you get a B and an A, or an A and a B? Well, then you're going to have type AB blood, because A and B are both dominant. When they get together, we call it codominant, and they will both be expressed together. Type O, because O is recessive, the only way you could end up with type O blood is if you inherit two recessive O alleles. Now this chart shows you what it actually means, like what it would look like, the real phenotype. Your blood type actually tells you what kind of antigens you have on your blood cells, your red blood cells, and what kind of antibodies you have in the fluid around your red blood cells. And if you get the wrong type of blood mixed with your blood, you could end up with a blood clot, and if it's too much of the wrong blood, it could kill you. So that's why blood type is kind of an important thing, but it's also interesting because it's determined by multiple alleles. So let's do a Punnett square using multiple alleles. Let's say we have one parent who is heterozygous for type A blood. So heterozygous for type A blood, the genotype would be A, and since heterozygous means the alleles are different, this one must be O. Okay? Now we're going to cross heterozygous type A blood with somebody who has type AB blood. Now anybody who has type AB blood is just going to be AB. You don't have to call it heterozygous. There's only one way to get type AB blood because they're codominant. It's just A and B. So you have to remember that A and B are dominant and that O is recessive. You're going to have to remember that. All right, let's go ahead and cross. I'm going to bring the A down. Now we do have some dominant, and we do have some recessive, so remember recessive goes second if it's recessive. O is recessive, so I'm going to put it a little bit to the right here when I bring it down because it's going to end up second. And I'm going to come across to my rows. I'm going to bring my A across since they're both dominant. Doesn't matter the order, they're the same. Bring my A across. A is dominant to O, so it goes in front. Now A and B, they are codominant, but we write it AB because A comes before B. I don't know why, we just do it that way. And over here, the B goes in front because B is also dominant to O. This means that there's a lot of different options. There's a 25% chance of the offspring having type B blood. They would be heterozygous for type B blood. There's a 25% chance of the child having type AB blood. And there's a 50% chance of this child having type A blood because both of these genotypes would result in the phenotype type A blood. So our genotypes and phenotypes often sound similar when we're talking about blood type. All right, once again, that was a tutorial on how to complete a Punnett square for a trait that has multiple alleles.